Today we're going to talk about finding angles using the sine, cos, and tan ratios. So our question here says, solve for x in each of the following. Round your final answers to 2 decimal places. So our first example here, we have a right angled triangle. I know that it's a right angled triangle because it has a little square in the corner. And our sine, cos, and tan ratios only work when we have a right angled triangle. Our right angled triangle has 2 labeled sides. We have one side of 17 meters, one side of 10 meters, and we want to find angle x. So when I'm trying to choose a method, the first thing I think about is Pythagorean theorem. So you can use Pythagorean theorem when you know 2 of the sides, but it only works if you're trying to find the third side. And I'm not trying to find a side, I'm trying to find an angle. And if I want to find an angle, I cannot use Pythagorean theorem. I need to use either sine, cos, or tan. So the first thing you should do is label your diagram. So the hypotenuse is always located across from that 90-degree angle, and it should be the longest side in your triangle. So this side over here, 17 meters, is my hypotenuse. To do the opposite and adjacent sides, you need to know your angle is. So I have this angle here. I don't know what it is, but I want to find it. So that's the angle that we're going to use. Directly across from that on the other side of the triangle, that's our opposite. And then our third side is the adjacent. Adjacent means beside. It's the side beside the angle that we're trying to find. So what I like to do is look at the 3 sides and see if there's one that I don't really know anything about or want to find anything about. So I notice that I know the adjacent and the hypotenuse. The side that's not labeled or I don't have any information about is the opposite. So I'm going to cross that one out, which leaves me with adjacent and hypotenuse. So to help me remember which combination of sides goes with which ratio, I like to remember the word SOHCAHTOA, which I just spelled wrong. So it's S-O-H-C-A-H-T-O-A, SOHCAHTOA. So I have adjacent and hypotenuse, that's A and H. The A and H would be cosine, or the C. So I want to make sure that we're using the ratio cosine. So cosine of angle A is A adjacent divided by H hypotenuse. So we're going to take our information from the triangle and just substitute it into our formula. So I have cosine. Now A is the angle. The angle in this question is x. So cosine of x equals adjacent, that's 10, divided by hypotenuse, that's 17. Now, all the other questions we've done up to this point using sine, cos, and tan, our next step has been to cross multiply. We would put a 1 underneath the cosine and then cross multiply. But when we were solving those, we were trying to solve for a side, and we knew one of the numbers in the fraction and the other was the x. So when we were solving and we cross multiplied, the x was part of this fraction. Today, the x is with the cosine. So I don't want to cross multiply because it isn't going to help me solve here. What I would like to do is find a way to get that x all by itself. So what I need to do is figure out a way to get rid of just a cosine. Not cosine with a number, but just a cosine. So what I want to know is what the opposite operation of cosine is. So if you think about a square, the opposite of a square is square root, or the opposite of multiplication is division, or the opposite of addition is subtraction. So the opposite or the inverse of a cosine is something we call the inverse cosine. And it's written as cosine with a weird little -1. It looks like an exponent. That's just the notation for inverse. And if you look at your calculator, you should notice that on your sine, cos, and tan buttons, above them it's got sine -1, cos -1, tan -1. So those are the inverse sine, cos, and tan. That's how you undo a sine, a cos, or a tan. So that means that x is going to be the inverse cosine, or cos to the -1 of, and then I'm going to put it in a bracket, 10 divided by 17. Now, to work this out on my calculator, it depends on the type of calculator you have. If you have a calculator where you see what you type in on the screen, so if you press cosine on your calculator and the word cosine shows up in the display, that's the kind of calculator we're talking about here. You would just type in what you see. Now, to get the inverse cosine, it is the second function or the shift of your cosine button. So you would do either second or shift, whatever you have, and then cosine, you need to put in a bracket, and then 10 divided by 17, close your bracket. Now on my calculator, because I don't see the word cosine when I press the cosine button, I have to do 10 divided by 17 first. So I'm going to do 10 divided by 17, and then I'm going to hit equals to figure out what that is, and then second cos. And I get that x is approximately 53 point, now it did ask for 2 decimal places here, so 9/6 would be 2 decimal places. I am just going to peek at the next number, it's an 8, which means that's going to round up to 0.97. So it's approximately 53.97. It's not meters because it's not a side length, it's an angle, so it should be in degrees. So our angle here is 53.97 degrees. Now, if you tried that and you didn't get that answer, please check that you are in degrees on your calculator. So it should say DEG, oops, can't see that, or just a D on your screen. Or try it again, make sure you do 10 divided by 17 equals, and then your inverse cosine. Even if you have a calculator where you see what you type in, you can actually do that as well. You could do 10 divided by 17 equals, and then your second cos, and then just hit equals, and it'll pop that answer back in for you, and you should get it to work out. So we'll do our next example in the next video.